ever wondered how drones are revolutionizing farming and relieving farmers of their age-old burdens? Today, we're diving deep into the world of autonomous agricultural drones for precision farming. These drones aren't just flying gadgets, they're the future of agriculture, promising to boost yields, reduce waste, and make farming more sustainable and efficient. Before we start, if you love exploring futuristic technologies and their real-world applications, make sure you subscribe to our channel, like this video, and hit the notification bell so you never miss out on our latest content. Also, we'd love to hear your thoughts on autonomous drones and farming. Share your opinions and questions in the comments below. Now, let's get right into it. Picture a world where farmers no longer have to guess which parts of their fields need water, fertilizer, or pesticide. Thanks to autonomous agricultural drones, this is becoming a reality. These drones can survey vast expanses of farmland, analyze crop health, and apply treatments with pinpoint accuracy, all without human intervention. This is what we call precision farming. To understand this better, let's look at how these drones work. Autonomous drones are equipped with advanced technologies like GPS, sensors, cameras, and algorithms that allow them to navigate and operate independently. They can fly over fields to collect data on soil conditions, crop health, and pest infestations. This data is then processed and analyzed to make informed decisions about where and when to apply water, fertilizer, and pesticides. Let me give you an example of how this works in practice. Imagine a farmer named John who grows corn on a large farm. Traditionally, John would have to manually inspect his fields to identify areas that need attention. This process is time-consuming and labor-intensive, and it's easy to miss problem spots. But with autonomous drones, John can simply program the drones to fly over his fields and capture higher-resolution images. These images are then analyzed to identify areas with poor crop health or pest infestations. The drones can then spray the affected areas with the right amount of pesticide, reducing waste and environmental impact. Another key advantage of autonomous drones is their ability to work around the clock. Unlike human labor, drones don't need breaks or sleep. They can operate in all weather conditions, day or night, ensuring that crops receive timely care. This is especially important in situations where rapid response is needed, such as during pest outbreaks or extreme weather events. But the benefits of autonomous drones go beyond just efficiency and precision. They also help farmers save money. By using drones to apply fertilizers and pesticides only where needed, farmers can significantly reduce their input costs. Additionally, drones can help optimize irrigation, ensuring that water is used efficiently and reducing water bills. This is not only good for the farmer's bottom line, but also for the environment. Let's take a closer look at some of the technologies that make these drones so effective. One of the key components is the multispectral camera. Unlike regular cameras, multispectral cameras can capture images in multiple wavelengths of light, including those not visible to the human eye. This allows the drones to detect subtle changes in plant health that may indicate disease or nutrient deficiencies. For example, healthy plants reflect more near-infrared light, so a drone equipped with a multispectral camera can create a detailed map showing which areas of the field are healthy and which are not. Another crucial technology is LiDAR, which stands for light detection and ranging. LiDAR uses laser pulses to create detailed 3D maps of the terrain. This is particularly useful for precision farming because it allows farmers to understand the topography of their fields and make better decisions about irrigation and planting. For instance, areas with slopes might require different irrigation strategies to prevent water runoff and soil erosion. Of course, all this data collected by the drones needs to be processed and analyzed. This is where machine learning and artificial intelligence come into play. By training algorithms on large datasets of agricultural images, researchers have developed models that can accurately identify signs of disease, pest infestations, and nutrient deficiencies. These models can then be used to analyze the data collected by the drones and provide actionable insights to the farmer. For example, let's consider a farmer named Emily who grows tomatoes. Emily's farm is susceptible to a common pest called the tomato hornworm. In the past, Emily would have to manually inspect each plant for signs of the pest, a task that could take days. But with autonomous drones, Emily can simply program the drones to fly over her fields and capture images. The images are then analyzed using machine learning algorithms to identify plants that show signs of the hornworm. The drones can then spray the affected plants with a targeted pesticide, saving Emily time and money while protecting her crop. Now, let's talk about some real-world examples of how autonomous drones are being used in agriculture. One notable example is the use of drones by vineyards in California's Napa Valley. Vineyards are particularly challenging to manage because grapevines require precise amounts of water and nutrients. Too much or too little can affect the quality of the grapes. To address this, some vineyards have started using autonomous drones equipped with multispectral cameras to monitor the health of the vines. The drones can identify areas of the vineyard that are stressed and need attention, allowing the vineyard managers to make precise adjustments to irrigation and fertilization. Another example comes from rice paddies in Southeast Asia. Rice farming is highly labor-intensive and requires careful management of water levels. Some rice farmers have started using drones to monitor the water levels in their paddies and ensure that they are optimal for rice growth. The drones can also identify areas with weed infestations and apply herbicides with precision, reducing the need for manual labor and increasing yields. But what about the future? How will autonomous drones continue to transform agriculture? One exciting possibility is the integration of drones with other advanced technologies like the Internet of Things, IoT, and blockchain. For instance, IoT sensors placed in the fields can collect real-time data on soil moisture, temperature, and other environmental conditions. This data can be transmitted to the drones, allowing them to make even more informed decisions about where and when to apply treatments. Blockchain technology, on the other hand, can be used to create transparent and immutable records of all the actions taken by the drones. This can help build trust with consumers by providing a detailed history of how the crops were grown and cared for. Imagine being able to scan a QR code on a package of tomatoes and see a complete record of how those tomatoes were cultivated, from planting to harvest. This level of transparency could revolutionize the food industry and give consumers more confidence in the quality and safety of their food. In addition to these technological advancements, there are also exciting opportunities for collaboration between farmers and tech companies. By working together, they can develop customized solutions that address the unique challenges of different types of farming. For example, a tech company might develop a specialized drone for monitoring coffee plantations in South America, or a drone designed to manage large-scale wheat farms in the Midwest. However, it's important to note that the widespread adoption of autonomous drones in agriculture also comes with challenges. One of the main obstacles is the initial cost of the drones and the necessary infrastructure. While the long-term benefits and savings are significant, the upfront investment can be a barrier for small-scale farmers. To address this, some governments and organizations are providing subsidies and financial assistance to help farmers adopt this technology. Another challenge is the need for training and education. Farmers need to learn how to use and maintain the drones, as well as how to interpret the data they collect. This requires a shift in mindset from traditional farming practices to a more tech-savvy approach. To facilitate this transition, agricultural extension services and educational institutions are offering training programs and resources to help farmers get up to speed. Despite these challenges, the potential benefits of autonomous agricultural drones are too significant to ignore. They represent a major leap forward in the quest for sustainable and efficient farming practices. By enabling precision agriculture, drones can help farmers produce more food with fewer resources, reducing the environmental impact of farming and contributing to global food security. Let's wrap this up with a look at the broader implications of this technology. Autonomous agricultural drones are not just a tool for improving crop yields. They are part of a larger movement towards smarter, more sustainable agriculture. As the global population continues to grow and climate change impacts agricultural productivity, the need for innovative solutions like these becomes increasingly urgent. By embracing technology and working towards a more data-driven approach to farming, we can create a future where agriculture is more efficient, resilient, and environmentally friendly. So there you have it, a deep dive into the world of autonomous agricultural drones for precision farming. These drones are changing the way we grow our food, making farming more efficient, sustainable, and precise. If you found this video insightful, don't forget to subscribe to our channel, like the video, and hit the notification bell so you never miss out on our future content. And don't forget to share your thoughts and questions in the comments below. Thanks for watching, and see you next time.